Okay, guys. So let's get started without any further ado. As mentioned earlier, in today's class, we're going to talk about one of the most important prerequisites for cybersecurity, which is networking fundamentals. Because again, as a cybersecurity professional, we need to understand how do computers transmit data to one another, okay, and what are IP addresses. And when you see or notice an IP in a log file, you need to understand where the attack is initiating from. So for that, you need to have a basic idea on certain important properties of IP addresses, classes in them, categories in them, what are public IPs, what are private IPs. We'll cover all that in this topic, networking fundamentals. Okay. Now, as mentioned earlier, when you talk about networking, there are three important definitions to know. Firstly, what is networking? What are networks? And what are hosts? So when you talk about networking, this is the practice of connecting information devices with each other. Okay, so in an organization, when you have various types of information systems, the process of, I would say, or the practice of connecting all these devices with one another so that they can share information or resources to one another is called as networking. Okay, and that collection of those devices or the group of those interconnected systems is called as a network. And each individual device or each individual information system in that network is called as a host. Now, again, when you talk about the examples of a host, it can be anything: a computer, a laptop, a printer, a router, a mobile phone, an IP camera, okay, speakers, all of these devices which are capable of connecting to each other and transmitting or receiving data from each other are called as hosts. Now, just like how we humans have names to address each other or to identify each other, these devices also have names to them. And that name is called as an IP address. Okay, so when you talk about IP, it stands for Internet Protocol, and this was developed by the US military in the late 1950s or 1960s, I would say. Okay, there were various versions of IP addresses. There was IP version 1, IP version 2, and IP version 3. They were not so successful. They were just experimental versions. What properly worked out was IPv4, or in short, Internet Protocol version 4 address. Okay, and that Internet Protocol version 4 address is what we're using even in today's world. Okay. So again, to define what an IP address is, as mentioned, each host on the network has a unique identifier. It's a unique, again, a name given to each device, and that is known as an IP address. And this allows for these devices to communicate with each other. Okay. So again, each host on the network has a unique identifier known as an IP address, and it allows for communication to occur, or for a possibility of communication between these devices. And these IP addresses have some important properties to them. First things first, this IP address is a 32-bit address. What it indicates by 32 bits is each bit is a value of 0 or 1. Your computers fundamentally communicate with each other in this language of zeros and ones, which is also commonly known as a binary language. Okay, binary in the sense two numbers. So fundamentally, when any data is stored on a computer, at the core level, it is stored in a sequence of zeros and ones. Okay. Now, our IP address specifically is a 32-bit address, which means it has 32 zeros and ones consecutively. And this 32-bit address again is divided in four equal parts of 8 bits each. Each of that 8-bit portion is known as an octet, or sometimes it can also be referred to as a byte. And each octet or byte is divided by a dot symbol as such. So this is typically what your IPv4 address looks like in the binary format or in the binary language of zeros and ones. But we humans are not so great at binary language. We don't understand binary so well. What we regularly use are decimal numbers, numbers from 0 to 9. Okay, so this binary number here can actually be converted to a human readable decimal number as such. So today we're going to learn how do we convert any binary number to a human readable decimal number first. Okay. So again, if you notice this number here, 11000000, this number is actually equivalent to 192, okay, in human readable language. Okay. This number 10101000 is actually equal to 168 in human readable or decimal language. So we'll now learn how do you convert or get these numbers. Okay. So before that, any questions or doubts up to this point? Merlin, Shashi, Roshan, Prejeet Patel, Asha. Okay. Assuming no questions, guys, Moving forward, let's learn how to convert any binary number to a human readable decimal number. So rule number one, let's assume we have this number here called 10101010 in the binary language. Now, when you want to convert that to a decimal number, okay, step number one or rule number one is you write down all the values of 2 to the power under each bit from right to left. So you start from 2 power 0 and go all the way up to 2 power 7. So under the rightmost bit, you have 2 power 0, then you have 2 power 1, then 2 power 2, then 2 power 3, then 2 power 4, then 2 power 5, then 2 power 6, and finally 2 power 7 here. Now, once you have all these values mentioned here, you multiply the lower number with the top one and keep on adding it to the next one. So this value 2 power 0 is multiplied with the top bit value and add to the next one. So 2 power 0 into 0 plus 2 power 1 into 1 plus 2 power 2 into 0 plus 2 power 3 into 1 plus 2 power 4 into 0 plus 2 power 5 into 1 plus 2 power 6 into 0 plus 2 power 7 into 1. So in that way, you would multiply each lower value with the top bit and add till the end to get the final decimal value. Now, if we start calculating this, we need to know the values of these numbers first, 2 power 0 all the way up to 2 power 7. So anything to the power 0 is always equal to 1. It's a mathematical rule. So 2 power 0 is 1. 2 power 1 is 2 itself. 2 power 2 is 2 into 2, that's 4. 2 power 3 is 8. 2 power 4 is 16. 2 power 5 is 32. 2 power 6 is 64. And 2 power 7 is 128. So now if you start calculating 2 power 0, that is 1 into 0, that's 0 itself. 2 power 1 into 1, 2 power 1 is 2. So 2 into 1, that's 2. 2 power 2 into 0, 0 again. 2 power 3 into 1, that's 8. 2 power 4 into 0, 0 again. 2 power 5 into 1, 32. 2 power 6 into 0, 0 again. And finally 2 power 7 into 1, that's 128. So if you add all this up, 128 plus 32, that's 160. 160 plus 8, 168. 168 plus 2, 170. So when you read the number 170 or 170, the computer reads it as 10101010. Something has a sequence of high frequency data and low frequency data. High, low, high, low, high, low, high, low. So when a computer reads this binary number, it understands that the user is entering 170 or 170. Okay. Is that clear? Everyone? Any questions or doubts up to this point? Aisha, Prijit Patel, Roshan, Shashi, Merlin. Hello, guys. I hope you're there, and I hope I'm not boring you out. Any questions? Please do respond.
No, no questions here. Thanks.
Merlin, Prijit, Roshan. Okay, perfect. Shashi, any questions on your end? Okay, perfect. Right, got your message. Now, if you have no questions regarding this, guys, I have two other examples here. So let's assume we have these numbers now, 0, 1, 0, 1, 0, 1, 0, 1, and all ones. If you have a pen and a paper beside you now, I want you to calculate the answers for those and give me the final decimal answer for it. Okay. So again, I've written down the values here from 2 power 0 to 2 power 7. These are the numbers 0, 1, 0, 1, 0, 1, 0, 1, and all ones 1, 1, 1, 1, 1, 1, 1, 1. Okay. What I want you to do is give me the decimal value for it. Again, all you have to do is multiply the lower value with the top bit and keep on progressing till the end. Okay. Take your time, no rush. Please calculate and give me decimal answers. And the logic is still not clear, and if you have any issues with the calculation or if you don't understand the procedure, please do not hesitate to let me know, guys. I can explain it again if needed. Okay. Do not, this is a course, again, which you're trying to learn. So when you're trying to learn something, never hesitate to ask questions. I can explain it as many times as required. Any answers for the first one, guys? 0101010101. Okay, I guess I've got some answers. Oh, okay, perfect answers, Shashi. Correct answers, actually. Others, guys?
Sir, can I ask some questions, sir?
Oh, just a second. Who was that? Yeah, Shashi, go ahead, please.
Sir, when we just do SQL queries, sir, there is a host name which we write into it, sir. So then what is the difference between host name and port number? Likewise, IP address. Is there any difference?
Yeah, again, when you talk about a host name or a domain name, that is for your understanding to remember that, Shashi. Okay, because these things are usually constant. IP addresses might keep changing, right? So today you might get a different IP for your server. Tomorrow that IP might change if it is being provided by your service provider. They might give you a different IP. So again, IP address is also an identity for your server, but a numerical address. A human translation for that would be your host name or the domain name. So if you take a website, let's say www.google.com, this domain name is for your remembrance. Okay. But this domain is actually a website which is hosted on a web server. So that server gets a public IP. Okay. So that is the identity for the server for the computers to know what device to identify. But we humans, since we can't remember these numbers, okay, we have the name instead. Okay. So these names and numbers are linked together in something called DNS servers. Okay. We'll come to that later on. But a simple answer for this is name, host names for your remembrance, and come for computers connection, their IP addresses. Okay. Is that clear?
Okay, sir.
Shashi, is that clear? I couldn't hear you.
Sir, is that true that when we are connected with VPNs, our IPs are keep on changing?
Yeah, definitely. You're connecting to the VPN server in between, right? So that acts as a proxy. So whatever proxy's IP would be, that would be the IP you would be connecting with to the server or to the target website. So definitely when you use a VPN, your IP will get modified. It will get changed. Or in cybersecurity terminology, so your IP gets spoofed. Okay. So on top of your original IP, you add an extra layer of other IPs. So that is called a spoofing. And that is possible with VPN servers.
Okay, sir.
Right. So again, guys, if you've not got the answer, no worries, nothing to worry. Let me show the calculations. So when you talk about 01010101 here, oh, perfect answers, Aisha. Correct answers again. So again, as mentioned, first things first, the first number. So let's do power 0 into 1 plus 2 power 1 into 0 plus 2 power 2 into 1 plus 2 power 3 into 0 plus 2 power 4 into 1 plus 2 power 5 into 0 plus 2 power 6 into 1 plus 2 power 7 into 0. So now when you start calculating that, anything into 1 is the value itself. So 2 power 0 into 1, that's 1. 2 power 1 into 0, anything into 0 is 0 itself. So here we have 0. 2 power 2 into 1, that's 4. 2 power 3 into 0, that's 0. 2 power 4 into 1, that's 16. 2 power 5 into 0, that's 0. 2 power 6 into 1, that's 64. And 2 power 7 into 0, that's 0 again. 64 plus 16, that's 80. 80 plus 4, 84. 84 plus 1, 85. Exact, correct decimal number for this binary number is 85. And when you have all ones, you just multiply and add all the numbers. So 2 power 0 into 1 plus 2 power 1 into 1 plus 2 power 2 into 1 all the way. So that would be 128 plus 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1. So if you start adding it up, you would get the final number as 255. Okay. So this is how you convert any number from a binary number to a human readable decimal number. Now you might have a question. Why are we learning this in the first place? So the reason I've been explaining you this conversion is so that we get the range of IP addresses, guys. So if I had to know what the first IP is, I simply have to put all zeros everywhere in each and every single octet. So 8 zeros here, 8 zeros here, 8 zeros here, 8 zeros here. And when you put all zeros, the decimal representation for that or the decimal conversion would simply be 0.0.0.0. That's your first IP address in the IPv4 range. And if we had to get the last IP, you simply put all ones everywhere. And when you put all ones, you just calculated and gave me the answer 255. So the last IP is 255.255.255.255. So from this, we can understand whenever you talk about IPv4 addresses, the number in any octet cannot exceed 255. Okay. So whatever IPs you have, they will always start with 0 in each and every octet and end at 255. They cannot cross it because you just now know logically an octet can only contain a maximum of 255 as a number, not more than that. Okay. So if someone ever asks you what is the range of IPs, this would be the range. And the logical reasoning behind this binary to decimal conversion of the octet with all ones is 255, not more than that. Okay. And if I had to calculate the total number of IPs now, so if you notice there are 32 bits, and in each bit there are two possibilities. So two possibilities here, two possibilities here, two possibilities here, like that for 32 bits. The total number of IPs would be 2 to the power 32. Okay. So each bit has two possibilities and there are 32 bits as such. So 2 into 2 into 2 into 2 into 2 like that, 2 to the power 32. And that would give you a number 4.3 billion IP addresses. So back then in 1950s or so, when IP addresses were invented, there were not many computers, there were not many people connected on the internet. You had no mobile phones as well then. Okay. So they thought 4.3 billion IPs are more than sufficient for the rest of eternity. But fast forward to 2023 today, each person has multiple devices and a population itself is 8 billion people. Okay. So 4.3 billion IPs would, again, seems a bit difficult to be manageable for the whole world. So that is why these IPs are again divided in various categories, guys. There's something called as classes, class A, B, C, D, and E. And there's something called as, again, public and private IPs in them. Okay. So we'll talk about these categories and all in the next session on Monday's class. Okay. But for now, let me talk about the sequence of these IPs. So how are these 4.3 billion IPs progressing one after the other? And then we'll end the session after that for today. Okay. So first things first, when you want to talk about the sequence of IPs, there are two simple rules again. Rule number one is you always start with the rightmost octet. So to explain this, let me write the list of IPs here. Okay, so this is our first IP here, 0.0.0.0. Okay, now rule number one is whenever you want to go to the next IP, always start incrementing from the rightmost octet. So if 00 is the first IP, next IP would be 01. So the rightmost octet has increased by 1. Then 02 is the next IP, then 03, then 04, then 05, then 06. This goes on all the way. It keeps on repeating. Okay, so after 06, you would have 0007, 0008, okay, 0009, 00010. This keeps on going all the way up to 254, 253, 254, 255. Now, after this, please remember, we can never have a value like 00026. This is not possible. Okay, the maximum number it can go up to is only 255. So now here comes rule number 2. After the rightmost octet is completely filled, when it reaches the maximum value, then you move to the left octet. So now the 0 now increases to 1. Okay, and this 255 always cycles back to the first number again, 0. So after 000255, next number would be 10. Now after 10 again, don't directly jump to 20, guys. That would be wrong again. Remember rule number 1, always progress with the rightmost octet. So after 10, you have 11, then 12, then 13, then 14, then 15. Goes all the way up to 1255. So if you notice, there's a pattern forming here. 00 to 0255, 10 to 1255, 20 to 2255, 30 to 3255, 40 to 4255. Like that, the pattern keeps on repeating. And somewhere down the line, you would have 2550 to 255, 255. Once both these octets are filled, what happens then? They cycle back to zeros. Next left octet changes by 1. So whatever cycle repeated all the way over here. So again, you have 00 again, if you notice. So 00 goes up to 0255. 10 goes to 1255. So whatever cycle repeated here from 000 up to 0255255, same cycle repeats again from 100 to 1255255, 200 to 2255255, 300 to 3255255, 400 to 4255255, 500 all the way up to 5255255, 600 up to 6255 255. This keeps on going all the way up to the value like 0254, oh sorry, 25300, then which goes up to 0253, 255, 255, then 25400 to 254, 255, 255, and finally 25500 up to 255, 255, 255. So if you notice now, whatever cycle repeated again, now since all these are 255s, they cycle back to zeros again, and this next zero changes to 1. Whatever cycle repeated from 0, 0, 0, 0, and went up to 0, 255, 255, 255. Same cycle repeats again from 1, 0, 0, 0 to 1, 255, 255, 255. From 2, 0, 0, 0 to 255, 255, 255. 3, 0, 0, 0 to 3, 255, 255, 255. Like that, 254, 0, 0, 0, 254, 255, 255, 255. And finally, 255, 0, 0, 0 up to 255, 255, 255, 255. There was the first number 0, 0, 0, 0, and here's the last number or last IP address. Okay, so this is how the IPs are progressing. And if someone had to count all the IPs from the first one to the last one, you would get a total of 4.3 billion IP addresses. Indeed, we did skip a lot of IPs in between, but this is how the sequence flows. Okay. But again, as mentioned, these 4.3 billion IPs are nowhere sufficient in today's world. Okay, so that is why we have a lot of categories in them again. There's something called as classes, class A, B, C, D, and E. And there's something called as public and private IPs. Okay, so we'll talk about the classes and public and private IPs in the next session on Monday's class. Okay, just in case if you have missed out this demo, guys, which I took yesterday, you can also join that demo on the Sunday as well. We do have a workshop on the Sunday at 10 a.m. or so Indian Standard Time. So you can join that workshop or demo to get a much more better idea on the whole course. Alternatively, if you want the recording, I'll be sharing the recording to your email addresses directly. Okay. So you can drop your emails in the chat box, guys. Shashi, Roshan, Patel, and I'll drop the recording of the previous session of the demo on the email address directly. Okay. Any questions, any doubts up to this point? Shashi, Merlin, Aisha, Patel, Roshan. Oh, got your email, Shashi. I'll drop the recording link to you shortly. Any other questions, guys, in the meanwhile? Okay, perfect. So yeah, that's that, guys. Nothing further. We'll exit the session over here. And we'll be connecting back on Monday at the same time to progress further on IP addresses. And as mentioned, if you want to get a demo on the previous, if you want to learn about a bit more in depth about this course, okay, you can join the demo, which is on this Sunday. Okay, you'll be getting the email link for that on your email, registered email for this meeting. And alternatively, if you want the recording, I'll be sharing the recording myself on your email address as well. Okay. Bye-bye. That's that, guys. Nothing further. I'll exit the session. Yeah. Anyone, any questions?
Sir, can we get the class notes, running notes, or should we write itself ourselves?
Yeah, sure. I'll share this notepad file as well, Shashi. And again, these materials and all are usually shared with students once they have registered for the course. So again, this material that I'm showing to you, where the presentation slides and all, those are usually shared after the students make a payment. But in the meanwhile, I can share this notes as such. Okay.
Okay.
Sure. And yeah, any other questions? Okay, guys. Assuming no questions, let me exit the session here. And let's connect back on Monday again on the same link. Progress much further on IP addresses, guys. Bye-bye. Thanks for joining the session today. See you on Monday again. Take care.
Thanks. Bye.
Thank you. Bye.